Now I'll explain the exercise, the Excel exercises in chapter 4. So I'll start from scratch. Here I'm going to do question 4.1. So here is the implementation of a basic arch model. So first we compute the log return that you already have done. Then we compute the squared return, again, that you already have done. So this is like basically the same thing that we have done before. Now the next thing we're going to do is slightly different to what we did before. So here we're going to do the Garch model. So the Garch model looks like this. So we're going to have an r squared and a sigma squared, and the whole thing is, okay, what do we put? This is going to be our sigma 0. So then what the book suggests is just use the variance of your returns, and that's basically going to be your starting variance. Now for the second one, we're going to use our omega and our omega alpha and beta. So we still don't have any values here. In a second I'm going to put them. So for now we're going to say, well, it's going to be omega, plus alpha times the return squared from the previous day, plus the beta times sigma squared. Now there's some cells we have to fix. So we have to fix all the i's, since those parameters are going to change. I do that by pressing F4 when I'm in that variable. So that's it, I've done it. Of course, I'm going to get an error for now. Actually, I'm getting 0. And then I'm going to drag this down. Finally, I'm going to do the likelihood function. So here is the sum from t equals to 1 to capital T of. So let's put that minus 0.5 times logarithm of 2 times pi minus 0.5 times logarithm of sigma squared minus 0.5 times r squared over sigma squared. And then I close parentheses and I click yes. Of course I'm getting a number here since I don't have parameters. So here I go to the book and I input the parameters that they suggest in the book. So in the book they suggest for alpha a value of 0.1, for beta a value of 0.85, and for omega it's going to be roughly a value of 0.000005. And then this ones, we're going to put them, we're going to copy paste them and put them also in the starting values. Now we're going to copy paste this log likelihood, and then the log likelihood function is going to be equal to the sum of all these values here. Now the next thing we're going to do, so now we have our log likelihood function with, that starts at 7,818. So we're going to go to solver. How do we go to solver? So we go here, data, and then we're going to have the solver here. If you don't have that, then you have to go to file, options, add-ins, and here Excel add-in, go, and then here you should have clicked on solver add-in. Since I already have it, I'm not going to do it again. So I just click cancel. So now you click on solver. And then here we have that what we want to, the objective is this log likelihood. We're going to maximize it. So I click here, set objective, and then we go 015. I can maximize, minimize. I'm going to maximize. Which cells I'm going to change? I'm going to change these 3 cells here. And then for now, I'm not going to set any constraints. Here you have some solver options. So you should click here on options. And if it doesn't work, then you go and you actually try to modify these options here. That's in case it doesn't work. So for the first time I'm going to do anything, I'm just going to run it as is. So I leave it like this. The restriction actually that you need is that alpha plus beta, it's lower than 1. So this is actually pretty tricky to put. What I did was I created a cell here at J13 that it's equal to alpha plus beta. And then I added here a constraint that says J13 is lower than or equal to 0.999999. The other constraint that you can add is that you want your omega to be greater than 0. So here you're going to put greater than or equal to point, and then you put, since you cannot put greater than 0, you do it this way, and off we go. Then after we have added these constraints, we're ready to solve, to find those maximums. Let's click solve and see what happens. Here at the bottom, you should see something changing. My computer right now is pretty slow, so that's why it's taking forever. So setting up problem, that's the very first thing it says. And then it should start running the iterations. 50% done, 83%, 99%, and then objective. So that's what we were starting at. So that's the solution 1. We're now in the trial solution number 15. So now we see that the log likelihood has increased, and actually that ends up being the answer. I'm gonna say that to keep that solution, and then these are the parameters we find. So these were our starting values, and this is what we actually end up finding. Now we're gonna do the right part. So the right part is very similar, but the only thing is that we're gonna have variance targeting. So here I'm also gonna start with this value, the 0.19. And I'm also going to have this same function that I have here, but I'm going to change the parameters. You can see exactly what I'm going to do. So let's leave the parameters the same. As you can see, they point to the cells and the cells here. So I'm going to make this one point to the upper one here, and I'm going to make this one's point to our new values. So the alpha points here, beta points here, the omega points here. There you go. Next thing I'm going to change, log likelihood is still going to be the same, so I'm just going to copy paste it. Just actually a pure copy paste. And finally, my starting values are going to be actually what I found as a result for alpha and beta. And then the second I'm going to tell you, so I'm going to copy paste these values, and then the omega, as you can see in the equation down below, the omega is also equal to 1 minus alpha minus beta times sigma squared, where that sigma squared is this long run variance. So I'm going to put this equal to 1 minus alpha minus beta times our sigma squared. Then I'm going to take the starting values, I'm going to copy paste them. But now, as you can see, I only have to estimate 2 parameters, because now the omega is not omega anymore, because sigma squared is already defined. So I just have to estimate alpha and beta. So I have this model. Let's copy paste this. Let's double check that this is actually working. It is. Solver once again. So now, still I have to add the sum here. Log likelihood values. Check what's going on here. Still I'm getting an error. So this would be the return squared. There you go. Once again, I check that everything's fine. So yeah, return squared, sigma squared, and I am the right ones. So now I click solver. Cell I'm going to maximize now is the O15, so this is the one I'm going to maximize. Now I'm going to change the just alpha and beta, remember that. And then I'm going to still have that restriction that alpha plus beta is lower than 1. I add this constraint, and then I solve. Look here, solve, and then I'm going to wait. Then we reach a maximum. We keep the solution of the solver, and we get a likelihood of 7,147. Whereas with 3 parameters, we get 7,844. Well, this concludes the introduction. The other exercises are very similar to this one. We added extra parameters to the models, and then we include the LR test. So remember to look at the description of the chapter where I explain the LR test and how to check whether there was an improvement or not over the previous model. Thank you for watching.